this conservation of mechanical energy principle, and we solve this example by our usual dynamic methods, that is applying the laws of motion, finding acceleration, then using equation of kinematics, and then we use the conservation of mechanical energy principle and we see whether the answer comes out to be same or not. So over here the question is, that is we have a 1 kg block, this is an inclined plane, the surface that is absolutely frictionless, this is 2 meter, this is a point mass body, so don't get into its what are the dimensions like. When it is released from here, then certainly the velocity will be increasing, and over here we have to find the velocity. So one, our usual method of dynamics, that is when we are using the laws of motion, then over here we see that is mg is acting in this direction, it has two components, mg sin theta is over here, this is theta, so mg cos theta, and over here this is normal reaction. We have done quite in detail in our laws of motion. I would strongly recommend that is be very good, excellent in laws of motion, because that is a foundation where you understand force and is a foundation of mechanics. So over here mg cos theta is equal to normal reaction, the body is coming like this, it is not jumping along the y-axis if we have taken this as y-axis, if we have taken this as x-axis. So mg sin theta is this way. So because of this, that is the force along the x-axis, this is the resultant force along the x-axis. Force is equal to mass into acceleration. So acceleration down the plane is going to be equal to g sin theta, taking g for convenience purposes, instead of 9.8 meter per second square, we have taken g as 10 meter per second square, and this sin 30, sin theta is, sin 30 is half, so it means it will coming down with the acceleration of 5 meter per second square. So if this is 2 meter, and suppose this length is L, hypotenuse is L, inclined plane length is L, so we know that sin 30 degree is going to be 2 by L, so L is going to be 2 by sin 30 degree, sin 30 is half, so obviously L is going to be 4 meter, elementary trigonometry. So over here to here it is going to be 4 meter, so this is going to be 4 meter. So when it is coming from here to here, we have find the acceleration 5 meter per second square. So then from position A to position B, if we apply equation of kinematics, because acceleration is constant, you know very well, that is you can apply equation of kinematics only if acceleration is constant. If it is not, A is changing, then certainly once again you will use the concepts of calculus only. So over here v square minus u square, that is velocity over here minus velocity over here, v square minus u square, initial velocity, and this stands for final velocity, this stands for initial velocity. V square minus u square is equal to 2, A is what? A is 5. What is S? S is 4. So V square comes out to be 40 root 40 meter per second. Now let's do this and let's find the value of velocity using conservation of mechanical energy principle. So let's write the answer over here, that is V has come out to be root 40 meter per second. Now we shall be finding the velocity using conservation of mechanical energy principle. So this is a question. So we have to find velocity over here. So when we are talking the mechanical energy, so mechanical energy is potential energy plus kinetic energy. Let's talk the two positions. This is position A, this is position B, and we take this as this level as our reference level. So it means mechanical energy at A is equal to mechanical energy at B. Whatsoever is the total mechanical energy over here is going to be equal to total mechanical energy over here. That is, we are applying conservation of mechanical energy principle. That is, sum total of potential energy plus kinetic energy is constant. So it means that is, we say P potential energy at A plus kinetic energy at A is equal to potential energy at B plus kinetic energy at B. What is potential energy at A? That is mg. What is h? H is not from here to here, h is the level. Suppose you scale a mountain, you have gone from here to here. So vertically how much, what is the height you have been elevated? You have been elevated by this height, not this length. Similarly, when the body has gone from here to here, it has gone down from this level to this level, that is, it has gone down by 2 meter only. And right now we are finding the potential energy, so mg h is from this reference level, this is going to be 2, mg2, plus kinetic energy. Kinetic energy at A over here is half m, it has been released from here, so velocity is 0, speed is 0. So half m 0 square. when it comes over here, that is potential B, that is mg. What is the height? This is a point mass. What is the height from here? That is 0. Plus kinetic energy half m, velocity over here just before striking the ground. It is not after striking the ground. Half m vb square, and we are supposed to find the value of vb. So it comes out to be mg, g let's take it as 10 into 2, this is 0, is equal to half m vb square. M and m they get cancelled, that it becomes out to be independent of mass. Whether you take it a 1 kg body or 20 kg body or whatsoever mass is taken, this acceleration will be independent of this mass, that is g sin theta. It is going to be 5 meter per second square in this particular case, and the velocity will also be independent of mass. We are seeing this. So vb square, 2 comes over here, 2 into 2, 4, 4 into 10, that is 40 meter square per second square, and v comes over here, that is root 40 meter per second. It comes out to be same what we have done, what we have found by the laws of motion or by the dynamics principle.